SSN accelerates time to market by simplifying the top-level DFT architecture. It decouples core-level DFT requirements from chip top-level resources. We also use a parallel bus that allows to distribute data along the chip without having a complicated TAM for multiple different retargeting and A2BG sessions. So the advantages with time enclosure with SSN are the scan signals are generated local by the scan host. So the scan host has built-in timing margin for all of those scan signals and the transition of those scan signals. Those scan signals are also generated locally, so they're not crossing hierarchical boundaries. So you're not having to close timing across hierarchical boundaries. SSN can test multiple identical cores by reusing the same scan data, mask and expect, and sharing it across all those identical cores. So those cores, so you're using the same data of one core and sharing it across 10, eliminating or reducing the scan data volume while testing identical cores. So one of the advantages of on-chip compare is that you can use input-only streaming mode, where you're using a go, no-go status on the TDO of the JTAG TDO for a pass-fail status, and you're not measuring anything on the output bus. So when you're using on-chip compare, you'll need a new pattern for diagnosis, because when you're using input-only streaming, you're only getting a go, no-go status on the JTAG TDO. So you need a new pattern in order to be able to do full diagnosis. So you can use high-speed I/O with SSN by using DDR clocking. When you're using DDR clocking, you're clocking data into the chip on both the rising and falling edges of the clock. And inside of the chip, the data will run at a slower rate, so that it's a little bit easier to close timing. And on the output side, we'll send data out, again, using both edges of the clock. So you have symmetry on the input and on the output of the bus. So with the in-system test controller with SSN, you can retarget patterns to the in-system test controller, and that will allow you to retarget those patterns through the in-system test controller, or you can multiplex that path to GPIOs in order to test it on the ATE and also in-system test. So the SSN patterns usually come up on the tester faster because they have more built-in margin from the scan host. That enables them to have a passing result and a better V-min on the tester. SSN reduces power activity within the chip because we distribute data across all the cores in a packetized form. So cores that have a larger scan data volume will get more bits per packet, and cores that have a smaller data volume will get fewer bits per packet. And when we're delivering data, each one of them will shift at different rates, having a constant draw of power on the tester. So you don't have a big ramp or a droop of power demand on the AT.